Dear students, so last class we studied about 7 segment LED display. Here, if you observe this, 7 segment LED displays are available in two different configurations, common anode and common cathode. Common anode configuration, the anode of the 8 segments are connected commonly. Anode of the 8 segments are connected commonly. Common cathode configuration, the 8 LED segments share a common cathode line. Common cathode line. As shown in the figure, you can see that things here, common anode and common cathode. Next is optocoupler. Optocoupler is a solid state device to isolate two parts of a circuit. Optocoupler combines an LED and phototransistor in a single housing or single package. In an electronic circuit, an optocoupler is used for suppressing the interferences in data communication, circuit isolations, high voltage separations, simultaneous separations, and signal intensifications. Optocouples can be used in either input circuits or in output circuits. Optocoupler is a solid state device to isolate two parts of a circuit. If you observe this very clearly, you can see circuit 1 and circuit 2. Here LED, higher LED we have used. Here phototransistor we have used. So circuit 1 and circuit 2 differently we can see that things. Highly separated we can see that things. Next is, wait. The following figure illustrates the use of optocoupler in a input circuit and output circuit of an embedded system with a microcontroller of the system. If you observe here, you see here, optocoupler is there. Here also, optocoupler is there. You can see that diagram itself says optocoupler is available ICs from different semiconductor manufacturers. So, wait. So this optocoupler is a solid state device to isolate two parts of a circuit. We can see that things. Here also you can see that one, phototransistor and LED. You can see that things in diagram. Very clearly it's visible. Next is, stepper motor. Stepper motor is an electromechanical device which generates a discrete displacement or motion in a response to the electrical signal. When we apply the electrical signal, stepper motor should rotate. That rotate is nothing but a displacement. Stepper motor produces discrete rotation in response to the DC voltage applied to it. Stepper motors are widely used in industrial embedded applications, consumer electronic products, robotics control systems. The paper feed mechanism of printer packs makes use of stepper motors for its functioning. Based on the coil winding arrangements, two-phase stepper motor is classified in two. They are unipolar and bipolar. Unipolar stepper motor contains two windings per phase. The direction of rotation clockwise or anti-clockwise of a stepper motor is controlled by changing the direction of current flow. The coils are represent A, B, C, D. Coil A and C carry current in opposite directions, A and C, phase 1. Similarly, B and D carry current in opposite directions for phase 2. Bipolar stepper motor contains a single winding per phase. For revising the motor rotation of current flow through the winding is revised dynamically. It requires complex circuit for current flow. The stepping of stepper motor can be implemented in different ways by changing the sequence of activations of the status winding. The different stepper motors supported by stepper motor explained in below, like pull step, wave step, half step. Pull step, if you observe, first one coil A is high, coil A is high, coil B is high. Then coil B is high, coil C is high. Then coil C is high, coil D is high. Then coil D and coil A is high. This is rotation. Then wave stepper, coil A high, then coil B high, second rotation, coil C high, third rotation, coil fourth rotation, coil D is high. Where if you observe this half steppers, there's a coil A is high, then coil A and B high, then coil B high, then B and C high, then coil C is high, then coil C and D high, then coil D high, then coil D and A high. So if you observe that things, okay, very clearly it's visible. Wait. Next, relay. Relay is an electromechanical device in embedded application. The relay unit acts as dynamic path selector for signals and powers. The relay unit contains a relay coil made up of insulated wire on a metal core and metal, yeah, with one more contacts. Relay works on electromagnetic principle. When a voltage is applied to the relay coil, current flows through the coil, which in turn generates a what I call magnetic field. Magnetic field attracts the core and moves the contact point. The movement of the contact point changes the power signal flow path. Relays available in different ways. Like if you observe this figure, it's very clearly observed. Relay coil is the single pole, single through, normal open will be there. Then single coil, single through, normally closed will be there. If you observe it is open, it's closed. Then it is single pole, double throw will be there. So single pole, single throw. This single pole, single through has only one path for information flow. The path is either open or closed or normal conditions. Or normal conditions. Wait. The normally open single pole single throw relay circuit is normally open. It becomes closed when the relay is energized. For normally closed single pole single throw configuration, circuit is normally closed. For normally closed single pole, circuit is closed. It becomes open when the relay is energized. The single pole double throw relay, there's two paths for the information flow. They are selected by energizing the relay. The relay is controlled using relay driver circuits connected to the port pin of the controller. A transistor is used for building a relay driver circuits as shown in the diagrams. Then piezo buzzer. Piezoelectronic device for generating audio indications in embedded applications. Piezoelectric buzzer contains a piezoelectric diagrams which produces audible sounds in response to the voltage applied to it. Piezoelectric buzzers are available in two types: self-driving, external driving. Self-driving circuit contains all the necessary components to generate sound at a predefined tone. External driving piezo buzzers support the generation of different tones. A piezo buzzer can be directly referred to the port pin of the processor control. Depending on the driving current requirement, the piezo buzzer can be interfaced using transistor-based driver circuit as shown in case of relay. Push button switch. Push button switch is an input device. Push button switch comes into two configurations, namely push to make, push to break. In the push to make configuration, switch is the open state and it makes circuit contacts when it's pushed to pressed. So push to make, word itself says push to make. So that switch is in the open state and it makes the circuit contact when it pushed or pressed. Push to break. Push to break is the switch is in the closed state and it breaks the circuit contact when it is pushed or pressed. So push to break. Push button stays closed. Push to make type open for push to break type statement. Push button is used for generating a memory pulses. In embedded applications, push button is generally used as a reset and start switch pulse generators. Okay, next one. Yeah. Next, keyboard. Keyboard is an input device, high pulse generator for user interfacing. If the number of keys required is very limited, push button switches can be used and they can be directly interfaced to the port pins for reading. However, there may be a situation demanding a large number of keys for user input. In a situations, it may not be possible to interface each keys to a port pin due to the limitation in the number of general purpose port pins available for the processor controls. Moreover, it's a wastage of port points. Next is programmable peripheral interfaces. We will study in the next class. Study well. All the best.